Hi there, I'd like to show you how to do this digital guitar stomp box from scratch using STM32 IDE. So we're going to start up STM32CubeIDE and try to begin a project from scratch. So before, what I did was I showed you how to copy a project from an existing one, and that's good, but sometimes I like to do it from scratch also, because sometimes some bad things that might be in the previous version might get into the new version, but it's always good to know how to do it from scratch. So we're going to close out the last project here, and yeah, we're going to close that out. So we go over here and say close project, and we're going to make a new project. So we're going to make a new one. Before, we did project from an existing IOC file, but today we're just going to do one from scratch. So here we're going to hit this STM32 project. So we're going to hit File, New, STM32 project. So it says initializing STM32 target selector. So we're using a Nucleo board, and so we're going to go do it from scratch and select our Nucleo board. So we go to on the target selection. So there's a dialog box that comes here up that's called target selection. We're going to hit board selector, and that's trying to find that, and we're going to find our Nucleo board. So it's Nucleo, and you see here they are. They're coming up. So we have an H7. Let's see, we have an H723ZG. This is it right here, H723ZG board. So we're going to click on here and hit next. So our project name, we're just going to add a new project here. It's called Sound-H723-3254-EX15. So all the other defaults here are good. We're going to hit next. And we're going to be using the firmware package for the H7 version 1.11.1. So we're going to just hit finish here. Initialize all peripherals with their default mode. I'll just say no for now. So we don't want any of the peripherals or minimize them because we have to take away a lot of stuff. So we want to decrease the amount of stuff we have to take away. So it's loading the IOC, and it's rendering the UI. So there's a couple other dialog boxes that you don't see that are coming up now. So it says rendering user interface, and it should be up in a second. So let's see it come up. So it says performing project creation, please wait for completion. So usually this doesn't take too long to do. Okay, so there it goes. So there's some default items that come up that we don't use that we want to get rid of here. So the way we do that is we go around, and a lot of these yellow things, we're going to just hit reset state. So we don't need that one. And we don't need this one. I think it comes up with some defaults for Ethernet that we're not using. So we're going to take away a lot of these yellow things here because they kind of get in the way. So we're going to just hit reset state, go around. And this one, I think this is a USB setup that we don't use. So we're getting rid of that. Here's another USB thing we don't use. So we'll get rid of that. And let's see, okay, more USB. So this is our virtual COM port. We do use that. We do use the LEDs, so we'll keep that. So we'll come over here and hit reset state. So this is a tricky part, configuring this. You kind of have to go around, get some experience working with the STM32 products to get the hang of this, of what you need and what you don't need. So I'm just going around deleting things we don't need, because we could use these pins for other things. So we're going to hit reset state. This is more Ethernet stuff that we don't use. Reset state. And I'm trying to see, let's see, this MCO, do we use that? So we do have to set up a clock. Yeah, I think I'm going to keep that there. And we'll see if we need it later. So, so this oscillator, I believe we need. And, okay, I believe we got that set. So I'm going to save this IOC file, but I'm not going to generate the code yet. So we got a little ways to go before we do that. I'm not going to generate the autocode. So the next thing we want to do is our clock configuration is an important part. And so what you have to do, you have to go in here under, I believe it's the clock setup is RCC. So we want to use the external crystal that's on the board. So I want to make sure we're set up properly with that. So what we want to do here is we want to bypass the clock source on our internal clock for a high-speed clock. And we want to use our crystal ceramic resonator. So that's built onto this board. And anything else we need to set here? Let's see, just going through. So I believe everything else here is good here. Let's see. Yeah, I believe that's all good there. So just going down here. So all that looks good. The defaults are good here. Okay, so that looks good. So now we want to go to our clock configuration just to make sure we're using this in the right way. So I want to try to get the maximum out of this, the maximum performance. So the most you could go is 550. So this the tools, it kind of automatically sets up the clock parameters for you. So I'm just going to type 550 in here and hit enter. And there's a dialog box that comes up. It says searching for a solution. And don't know if you'll see that or not, but it's searching for a solution there to see what it needs to do to give me the maximum performance. And it's saying to wait a little bit here. So we're waiting and see what it comes up with. This is a pretty big page here of all the things you need, all the clock parameters. So this is one of their more advanced chips. So I believe it did set that up, but I want to use the crystal, which is an 8 megahertz crystal that's built onto the board. So I'm gonna click on here. So it didn't quite do it. Let me do it again. I think it was using the internal clock. So we'll do that again. And you could possibly use the internal clock. Maybe that'll work also. So, but this nuclear board happens to have an external crystal on it that's 8 megahertz. So it uses a lot of phase lock loops to get the 8 megahertz up to the 550 megahertz that you need to run the processor. So it's pretty neat. It has a lot of phase lock loops built into it. So it did adjust these. I want to make sure the timers are also, they have to be 275 megahertz. So that's an important number here. So I'm going to go around and look through here and see if everything here looks good. So we're right. So we need so we want to so that looks good here so far. I know this thing, we want to get this to be 24x. We want to get that a little higher. And so this thing we want only divide by 1. I have to do a couple other things here. And we want this to be a times 25. So these are used for some of the A to Ds and some of the other peripherals that are built onto the chip that we need. So I can't quite set anything here yet, but I'm going to go around and see what we could set here. So so the other things we need are let's see. Okay, we'll come back to this a little bit later because we'll be able to set things when some of our other peripherals haven't been quite set all the way yet. So we're going to come back to this a little bit later. So we're going to start setting some of the peripherals. So the first thing I want to start setting is the ADC. So this ADC is used to read the pots, to adjust some of the parameters real time as you turn the pots. So there's 6 pots on this device. So we're going to set this up, and so we have to set up for the 6 A to Ds. They're going to be 16-bit single-ended. So I'm setting up number 1. So I kind of skip around a little bit. Is the reason you don't have to do it this way, but the reason why I did it because I had some boards that had some of the A to Ds were damaged. So they're very easy to damage, the ADCs. So so I was trying to pick the ones that weren't damaged on the board. So I'm going to channel 1, channel 5, channel 6, 11. I have a new board in here, so I don't have to worry about the damage anymore. But I had one that was damaged. Only so many of the interfaces worked. I guess they got overdriven, so you have to be careful with that. Okay, so I'm using channel 2, channel 5, channel 6, channel 11, channel 15, and channel 16, all single-ended. Okay, so I have to go start setting the parameters. So I'm going to use DMA on this. So I hit DMA settings. So I'm going to add ADC1. So I want over here, I want this to be circular and data width word. So, and I want the memory to increment, so that's good. So we'll go back to parameter setting. So independent mode is good. This is good here. So we're using 16-bit. So end of conversion selection, we want end of the sequence. So we have 6 converters. So our conversion mode is going to be DMA circular mode. Okay, so some things depend on other things, and so if they're not previously set, you won't be able to select it. So I'm going to come back to this. I should probably go and set the timers. Let me go set the timers now. Then we'll come back to this. So I'm going to set our timers because the ADC depends on the timers. So timer 3 is our main timer that sets our 20,000 hertz frame time. And I'll go through some of the math, hopefully a little bit later on how I figured out how to set the numbers to this. So timer 3 is going to, okay, so anything I need to change here is I want to use the internal clock. And channel 1 is going to be output compare, no output. So what I'm doing is I'm setting I'm going to use it as a software timer, a countdown timer. So when it counts down and to 0, it'll send out an interrupt that'll restart the frame for the main frame here is 20,000 hertz. So the other thing I need to set is here to get to 20,000 hertz, I need to set this to 13,749. So I try to keep mostly everything at the defaults. There's only a couple things here I changed, so that's one of them. So I want to do the trigger event is going to be output compare of the comparator 1 reference. Okay, so when it hits the 1377.49, cycles. So I could do maybe 13,749 instructions. I guess that times 2 because the timer is running at 275 megahertz, but the processor runs twice that at 550 in this one. So I could get quite a few instructions in there in the frame. So the last thing I want to do here is I want to select is the mode here. So I want to do toggle on match. Okay. So I got that one set up. So I have to do one other thing here for the nested vector interrupt controller. So I want to enable this as an interrupt, and I don't believe I could do it here though. I have to go later. I'll go back to this and set that. So we'll move on. So it's kind of an iterative thing. Some things you could set, and some things you can't set to them. And so we're going to go to timer 4. So I believe we want I believe it's either a 50 or a 25 hertz sampling of the A to D converter to read the pots. So we're going to set that up now. So I'm going to use internal clocks. It's a similar thing again, but this time on this one I don't need to set an interrupt. So I just need the interrupt to start the frame, but I don't really need it for the ADC. So I'm going to do output, same thing, output compare, no output here for channel 1. So now my prescaler is 199, and this has before the last timer 2 is a 20,000 hertz. I believe this one is only a 50 hertz one. So I'll go back through the math and show you how to set how I know how to set these. So the same thing, the trigger event is going to be output compare, and mode is going to be toggle on match. Okay, so that's good for that. So it is much easier if you already have something made that you could copy from, and usually it's an iterative thing. As I do the next build, I'll copy from a previous project, but I just wanted to go through and show you how to do it from scratch if you didn't have a previous project. So now we're going to go back to ADC1, and we could set some things that we couldn't set before because I didn't have timer 4 set up. So we're going to have, there's 6 A to D converters here, so I'm going to set that to 6. So the external trigger is going to be based off of, okay, you have to wait a little bit sometimes after you put the 6 in. It's like setting up the drivers. Okay, so once it jumps like that, you know it's ready. So I want to do timer 4. So that's our 50 hertz timer to sample the ADC. So we want to do timer 4 trigger out event. Okay, so we just want to trigger detection on the rising edge, so that's good. So we're going to order these. So the first sample is going to be channel 2, so that's good. So the second sample we're going to do is channel 16, so they don't have to be in any particular order. But I'm just setting it to this order because I had a board I told you before that had a failed A to D interface. So rank 3 is going to be channel 3, so it's going to do in that order. And 4 is channel 6. And just because I had some that were failed, I was picking out the ones that were still good. So that's why it's got a weird order. Normally I would just do it like 1, 2, 3, 4, 5, 6. But because I had some failures, I'm doing it in this odd order. Anyway, this is a good educational experience to show that you don't have to do it in a regular numerical order. So I have, so I have channel 2, 16, 5, 6, and 15. So I believe that's it for the ADC. So now I'm going to set the DACs. Now the DACs I'm not really using anything, but I'm just kind of reserving them in case I do need to use it in the future. So they're pretty easy. So all I have to do is hit this, only connect it to external pin. So these are 12-bit DACs. So I'll set up those two. And just for future use, I don't use DMA for this, so it's a little bit easier to set up. So now I'm going to set up the I2C interface that's used for the audio codec. So this is a control interface. So I'm using I2C1. So I just, it says I2C, select I2C1. So I want I2C. And it's all I want to do is put this in fast mode instead of standard mode. So fast mode is a 400 kilohertz mode. So that's good. So we want I2C2, and we want to set that up. So that's used for the LCD display. So I'm going to enable that. And we also want that to be fast mode, which is the 400 kilohertz. So now I want to set up the I2S interface, and that's the main interface between the audio codec. It sends the data back and forth, and it's a 64-bit message. It transmits and receives at the same time. So it's a pretty fast interface for the audio. So I'm going to select I2S. So I need this to be full duplex master, so it's going to transmit and receive at the same time. And this one, this codec, which is the Texas Instruments TLV 320 AIC 3254. It does have a master clock output, so I'm going to turn that on. So we're going to use 32 bits data on the 32-bit data frame, and we're going to run this at 48 kilohertz. So we're going to do the only other thing we need to change here relative to the defaults is 24-bit data alignment left. So now we got to go set up the DMA. So this is going to run in the background under DMA. So I'm going to select the receive interface. So let's see, we're going to select that. And what I need to do is just making sure I set up the same as I set it up before. So we're doing, it actually uses a SPI interface and kind of converts it to I2S. So we want to use DMA stream 3, and it's peripheral to memory. So it's the same deal again. We want to use a circular buffer and do word. So that looks good there. So we want to add the transmitter. So this thing's going to be transmitting and receiving at the same time. So DMA 1 stream 1 is good. And the same deal here. We want to use a circular buffer and use word format here. So that looks good for that. The next thing we want to check is our system. This is just a quick check here. So we want this systic to be set, and we I believe it needs to be on for debugging, but we're not changing anything here. So that's good for that. So the last thing we have here is this UART3 that we use for instrumentation. So this is it's used to help debug the system. So we want to turn this on asynchronous. And all the defaults here are good. We want the 115,200 bits per second. So that looks good there. So now we're going to go around and set some of our discrete inputs up. So the best way to do it is to focus in on here. So let's see. So we have we have switch 1 here. So I'm going to focus in here. So switch 1 discrete input is going to be right here. So we're just going to select this and hit this as a GPIO input. And not going to put any names in there yet. And let's see. So we want, we got to find PA2. Let's see if you can find. Sometimes these things are so big, it's hard to find the pin that you're looking for, but here's PA2. So we want to make this a GPIO input. So that's good there. And some of the defaults are are good the way they are. So we want PE10. So here's PE10. Same deal as GPIO input. And we want PE12 as a GPIO input. And we want PE15 next as a GPIO input. And we want PB11 as a GPIO input. And we want was PD11. Let's see if we can find it. Here's PD11. So this is a GPIO input. And PE0. Let's see if we can find PE0. It's right up here as a GPIO input. So now we're going to set these GPIO inputs up. So a lot of different ways of getting there. So one way to do it is to, let's see, we could either maybe look at system view. So here's GPIO. Okay, so we want to set our PE2 up. So this is input mode, and we are going to use a pull up. And so this one's going to be called switch 1. So there's a little bit of delay in typing it in. It's got to think about it. Okay. And then PA2. So that one also has a pull up on it. And that one's called up underscore switch underscore 10S. So that's our 10 up counter. So we got to wait for the typing to catch up there. So there's a lot of checking that goes on. So our next one is PE10 right here. So PE10 also has a pull up. And that one is called switch 4. Then we got PE12, which has a pull up. And that one is called switch 2. So now we have PE15. So we're going to put the pull up on that because it's a discrete input. And that one's called down switch 10S. Down switch. So that counts down 10 effects. Okay, so the next one we have is PB11. And that's got a pull up on it. And that's called down switch underscore 1S. Down switch underscore 1S. Now we got PD11, and that's a pull up, and that's called switch 3. Now we got PE0, which is a pull up, and that's called up underscore switch underscore 1S. So I believe I got all of them now. So now I wanted to get back to the nested vector interrupt controller because I had to set one thing on that. And it wouldn't let me change it before, but you have to go to the right area. So this it's this timer 3. That's the only one interrupt I have that I set, and everything else is set automatically. So I wanted to put that as a preemption priority of 9. So, oops, lost it. Okay, got that. So there's a lot of checking that takes place when you do this. So I want to go back to the go back to the clock configuration and make sure things are set properly there. I couldn't set some of the things the last time because my peripherals weren't quite set up. So I know this one I want to set to 4. So let's see, this one is right 68.1, so that looks good in there. Okay, so I have another sheet of paper here I'm looking at. So this is good there to help me with this. So I want my important thing is the SPI2 clock because that's what drives the I2S interface. So I want that at 50 megahertz. So that's set right there. So that's good there. And let's see. So I'm just searching around in here to see what might need to be corrected. So this one looks good. The things like outlined or in blue are the things that we're using. So this one looks good here for our I2C interface. And just going to check here. So our main CPU clock is 550 megahertz, but all our peripheral clocks are 275 megahertz. So that's good. All coming out of this 8 megahertz oscillator crystal that's on the happens to be on the nuclear board. So let's see, I'm going down here and checking a few more things here with our clocks. So let's see. So we want our ADC clock over here. Want to make sure that that's set properly. So that's good there. So I think our clocks are good to go. So now, start. So now I want to go to our project manager, and I want to get control to some of the ordering here, the way functions are called. Like sometimes it doesn't really matter, but what the order is, but sometimes it does. So I just trying to be consistent in the order here. So these things you can't change and they're fixed, but I want to get, so the ADC's next, the DAC is next, I2 C1. So I want to get our timer 3 up there. And I want to get the UART after the timer 3. And this is just the way I had it ordered before. I want to get timer 4 after the UART. But it might not really matter in a lot of cases. So I want to get our I2S there and I2C down there. Okay, so that looks good there. So now I want to look at our nested vector interrupt controller and just make sure I couldn't set some of the things that wouldn't let me set before. So so over here I want okay, so some things like generate IRQ handler. So I want all these false up here. So I'm going to set all these. Except for the things that I'm setting. I want those to be true. So we have an interrupt for assist tick timer, the DMA, and the timer 3 is really the only thing I care about here. And then likewise for this, so that's good there. So we still have our 9 there. So that looks good. So maybe it's time to almost code this. So that looks pretty good. So I'm going to save this and have it auto code. So do you want to generate code? Yes. So we're going to let this generate the code. So it gives me a nice template, device configuration tool, updating code. So we're doing this for this example 15. So I'm doing it from scratch. So this is good. If you've never been through this before, it's always good to go through this. So it's done that. So now I have this project here. Just want to open this up here. Fell open. Let's see, there it goes. Okay. So the only two files I really deal with is this main and this one, the interrupt handler. So we're going to start putting code in here from the previous project, and then I'll try to compile it, see if it'll compile. So I have code from the last build I did, so I'm going to go in this main.c. This is the new design, and the old design is over here that I'm going to copy the code from. So the first thing, so there's these user areas, and we're going to fill in those user areas. So this is our user code begin. This is our include, so I'm going to cut and paste it from the last project I did. So this is mostly all comments, and so it ends there. There's some includes there, so I go copy it. Then I'm going to go here, and it goes right in there. The user code begin includes. So I'm going to paste that in there. So the only thing I really changed here is I'm going to update just some comments for this build. So this one is 15, and it was derived from 14. And it's just the purpose of this is just to make this IOC file from scratch. Okay, so the next bit of code to put in is this private defined area. So it's just a small area of some defines I had. So I'm going to drop that in over here. So I like to put a space in between here, just between the user code begin and user code end. So let's see. So the next area are these private variables. Okay, so we're going to go in here, and this is a pretty big piece. It has all the parameters for all the effects, all the initialization of those. So I'm going down. I have 43 effects programmed in here right now, so I could add more as I just come in. So I want to add that here in the private variable section. So I got that added in. Okay. So next, these are a lot of defines in here for subroutines. So I want to put that in to it. That goes in here. So that's in there. So the next section of code that isn't auto-generated is this user code section 2. So this has all the code that runs. It only needs to run one time. So that ends here. So it's all the initialization of the drivers. So I put that in there. And go back here a little bit. And the only thing I wanted to change in here is for the instrumentation, I'll just update the build number here. So this is our main code that runs 20,000. This is our 20,000 frame update loop. So that's pretty big piece of code there for the 43 effects. And it has all the real-time processing. So I'm going down and I'm going to copy that in. It's the main while loop that's in the code. And getting through the effects there. And this is for the pots. And the codec, the 32-bit A to D and D to A there. So that ends right there. Okay. So I'm going to copy that. I'll hit copy. And it's right here. So we're going to paste it in there. So that looks good. Just wanted to back up here a little bit to see how the spacing is on there. So that looks pretty good. Okay, so the last bit of code is this the subroutines, few subroutines I have in here. It's user code 4. So I have some subroutines. Not too many, but so that ends right there. That piece of code. So you save these like little code segments and put them in. Now, once you put it in, and if you need to add a peripheral, it doesn't change. Like when the auto codes, it doesn't change anything between these user codes areas. So that's kind of nice. So now we're gonna do off the interrupt handler, and there isn't too much code there. You want to kind of minimize that. So this all I had was 2 lines of code I need to put in there. So this is just to initialize this interrupt flag. So I go back and I'm going to put that in here in 0. And this is just for timer 3. So what it does is that when it goes through, if you have an interrupt, it sets the interrupt flag back to 1. So the next go around, like the main code sets it to 0. So when it comes in here, it sets it to 1. So in the first time through, it will run that real-time code. So that's what maintains the 20,000 hertz update rate. So that's that little piece of code is sometimes hard to find. Here it is right there. Interrupt flag equals 1. So I go back now and want to put that in there. So I have interrupt flag equals 1. Okay. Okay, so now we'll go back to main here. And I'm going to save this, save everything. Okay, so the other thing I have to do is, the other thing I have to do in this project, there's a couple other little things. Not too much. So you go to properties. Yeah, I'll do that again. So I go to project, properties. And so I want to go here to C++ build and open this up. So I have some settings here. You want to hit settings. So the one thing is, the MCU settings. So we use this printf and scanf. So I want to check that off and hit apply and close. Okay, so the other thing that we have is, if I can find it, I got to find the directory where the library is for the math library. And I'm going to get that, bring it up here. So my workspace, the STM32 workspace, there's a repository directory. So I want to go here, and I hate this kind of view. I'm going to view details, and I want to go to here where the drivers are. So this is STM32Cube. This is where the HAL directory drivers are. So we're going to go to drivers. So CMOS, and we want to go to DSP and include. So this is our headers for the math library, that just using sines and cosines. So I'm going to copy this, and then we're going to go back here to project, properties, and then so we want to add this include path for the compiler to be able to know that that's where our library is, our math library. So I hit add. So it looks like it's already in there. So I just hit OK there and hit apply, and can rebuild the index and apply and close. Okay, so now I want to see if I can compile this without any errors. So that'll be something if it makes it through. Let's see. Okay, so we're going to do that. So we're going to hit the compile button here. Well, to do the build, we're not going to load it into the processor yet. And let it go through the compilation. Great. Yeah, we didn't get any errors, warnings. That's good. Okay, good sign there. Okay, so now it's time to try to load it into the processor. See if we can get that to work. So now we're going to plug in our device, the USB, to see if we could program it. So I plug that in, and this comes up, which is a good sign, being I plugged in the Nucleo board. So now we're going to program it for the first time. So we want to use this debug over here. So we'll hit that. Okay. Yeah, we have to go back here. And let's see. Saying there's no launches, but we'll try to rebuild this just so it knows this is our launch. And let's try it again here. Okay, so the first time it goes through this, it remembers it afterwards using existing workspace settings for this is example 15, so we're going to hit OK there. And I'm hoping it's going to program the device. So it downloaded the code, downloads pretty fast. And we want to look at some of our live expressions. The main thing is this frame counter and the real time. So it starts off right after the main, the debugger. So we hit this to resume, and let's see if it looks like it's going to work. Okay, that looks pretty good. You can see the frame counter. It updates 20,000 times a second. This is our real time. So that's 7.9 seconds, 10 seconds. Okay, so that looks good. So we're going to listen to this, see how it sounds with the guitar now. Yeah, I'd like to talk to you about how timer 3 and timer 4 were set. So timer 3 is used to set to 20,000 hertz frame time. So there were some parameters. It was called the prescaler and auto reload counter. So that was the prescaler was set. So the way it works is the sample frequency is equal to the clock frequency divided by the prescaler plus 1 divided by the auto reload plus 1 register. Okay, so the prescaler was set to 0 and the auto reload was set to 13,749. So if you go through this formula, 275 megahertz divided by the prescaler, which is 0, divided by 1, and divide that by, you have to add 1 to the auto reload, 13,750. That's equal to 20,000. So that's why I had to set the auto reload to that number and the prescaler to that number. Now timer 4 is used to set the 50 hertz update rate for ADC1, and it's the same thing again. So in that case, the prescaler was set to 1999 and the auto reload was set to 2749. So the sample frequency is in that case is and I hate this thing is equal to 275 million divided by 2000 divided by 2750 was equal 50. So that's why the timers had to be set to those values. So these are auto reload timers, in that they what they do when they run out, they reset themselves and auto reload. So after in the case of the ADC, 50 times a second, this counter auto reloads itself, and for the timer 3, it's 20,000 hertz, but timer 3 also throws out an interrupt to run that code, 20,000 hertz. Now, in the case of the ADC, there isn't any code. I just needed to set that. It just automatically sets the ADC to run at that point, at that time. There's no interrupt needed because there's no code ran at that for that. Okay, well, thanks a lot for watching this. If you're interested in the STM32 for the digital stomp box, this is part 4, going through Scratch on how to configure the Nucleo board to be able to use that digital stomp box. Bye now.